Lesson 9.2, Simplifying Square Roots. Simplest form of a radical expression is when no factor of the expression under the radical sign has any perfect square factor other than 1. Remember, a perfect square factor means it's going to get you a whole number answer. There are no fractions under the radical sign, and there are no radical signs in the denominator of any fraction. So these are the three parts that we're looking for. The first property we have is the product property of square roots. Basically, if you have two numbers underneath the square root, or actually even if you just have one, you can split it up into two different square roots as long as a and b are greater than 0. So for example, 9 times 7 you can split it up into 9 and split it up into 7 because 9 is a perfect square root, so we can simplify that into 3. But keep the square root of 7 because it's not a perfect square root. 150. First factor using greatest perfect square factors. So give me two numbers that make 150, and one of them should at least be a perfect square root. 25 and 6. 25, is a perfect, well, actually both of them are. 25 and 6 are perfect square roots. So if I split them up, I can take square root of 25 is 5, square root of 25 is 5, square root of 6, actually, I was wrong. This is not a perfect square root because obviously 3 times 3 is 9, 2 times 2 is 4, so there is no perfect square root. So the simplest we can go is this. We can also simplify a variable expression. Let's separate the 18 and the t squared. 18 is 9 and 2. 9's perfect. Well, let's actually make them all each own square roots. 9 is perfect. It becomes 3. 2's not. T squared, to get rid of this square, we square root it. So we actually are left with just t. So you have here 3 square root 2 times t, or 3t. We're just going to move the t over, have the square root last. So the square root should always be last in your answer. Okay, let's try some of these. 75, I can split up into 25 times the square root of 3. Solve from there. You have 5 square root of 3. 25 can be solved because it's a perfect square. 80. Again, we're trying to find perfect square roots, so you kind of have to do some guessing and checking here. I can get 80 by doing 8 times 10, but 8 and 10 both aren't perfect. How about 4 times 20? Well, 4 is perfect. I could do that. It's 2 times 2. That's going to get me 2 square root of 20. Now, is there anything else 20 can go into? Well, yeah, another 4 times 5. So I can kind of do two types. So I probably could have gotten a bigger number than 4 at the beginning. But this is just another way to simplify. So we have 2 times with another 2 square root of 5. So I'm going to be left with 4 square root of 5. For 3, we're going to split 24 up. Again, we're trying to find a perfect square root. So let's think about what makes 24. 12 and 2, not perfect square roots. 6 and 4, well 4 is. 8 and 3. Let's try 6 and 4. So we know 4 is perfect, 6 is not. Then we have r squared. We can simplify the 2, just does 4 into the 2. We can get rid of the square because to undo a square, you square root it. You're just left with r. Put the r next to the 2, and then square root of 6. $56. 8 and 7 make 56. That's not going to help me. What else can make 56? Well, we can do 28 and 2. That's not going to help me either. 4 and 14. Okay, well, let's try this because we know 4 is perfect. So, simplify the square root of 4, which is 2. 14, you can't do anything to. M squared becomes just M. Now, 14, let's see, I could do 7 and 2, but that's still not going to be perfect, so it's not going to help. So I have 2M square root of 14. The quotient property of square roots basically says the same thing. If you have a fraction that you're square rooting, you can separate them into 2 square roots and then find the square roots of the perfect squares, the ones that are going to give you whole numbers. So 17 and 25 we separate into square root of 17, square root of 25. We know 25 is 5 times 5, so we can simplify that to 5. Let's try some down here at the checkpoint. You can simplify 5 and 9. That becomes square root of 5 over 3. 21 and square root of 64. 21's nothing. Isn't 64 8? With 7 we have some variables. Square root of 16 z over square root of 49. Okay, be careful. You have to actually simplify the top as well into 2 separate square roots. So what are you left with? Try this one on your own. Remembering that 16 square root and square root of 49 are perfect. Number 8, I'm going to split up the top. So we're kind of doing the product property with the quotient property. Number 8, square root of 32, that's not perfect, but 32 does divide into 4 and 8, so I actually could keep going. Actually, maybe I want to do something even better than that, which is 16 and 2. So let me erase that. 16 and 2 would be better because 16 is perfect. 4 and 4, right? I'll finish number 8 for you. So, square root of 16 is, actually you can do this one on your own. Square root of 16 is perfect. Square root of 2 is not. You can get rid of the square root of y squared, and you can simplify the square root of 81. Go ahead and simplify that. See Mrs. Shea to get your answers checked.